Good morning, everybody. This is a live severe weather briefing with high plains insanity to discuss today from southeastern Wyoming down through eastern Colorado. Looks like later on this afternoon, starting at about 3 p.m., that's when that threat for very large hail is going to begin. And I have to decide this morning whether I'm going to be targeting southeastern Wyoming or supercells that'll be developing off the notorious Palmer Divide later on today. That's an area of elevated terrain just to the east of the Front Range, that's to the southwest of Denver, that often fires storms down there. Those storms will often move down through the Black Forest area, Simla, maybe near into the south of the Lyman area. And it looks like we're going to have southeasterly movers today. Here you can see Gizmo, more than fired up to be chasing later on today. We were out in northern Colorado yesterday chasing as well. And here you can see some of the footage from that yesterday. Also a big hail producing day. There you can see a time lapse of that supercell that was approaching the Kersey, Colorado area. The well-defined mesocyclone. This storm was just a little bit too high base to develop a tornado threat. There was a storm that developed earlier in the day that laid out an outflow boundary, and that helped to modify the air mass a little bit, shifting those surface winds more over to a northerly direction. But with just a little bit higher dew points, I do think there could have been at least an isolated noodle potential with these supercells that went up across northern Colorado. But those dew points were about 30, dew point spreads were about 30 degrees, with the dew points in the low to mid 50s, temperatures near 90, even the low 90s in the vicinity of that Denver convergence zone. Today the moisture is a little bit better, a couple degrees higher based on the morning surface map. Still plenty of bulk shear, similar to yesterday, and with the dew points just a little bit higher, there is a non-zero tornado threat as well. The Storm Prediction Center has that 2% tornado risk from southeastern Wyoming down along the I-25 corridor, including the Palmer Divide as well. And here you can see some of that hail intercepted yesterday. Up to golf ball size in spots, there were a couple reports of 2-inch diameter hail near the Eaton, Colorado area. And I think that the hail sizes are going to be a little bit bigger. The supercells are going to be a little bit stronger today, and there is a chance of an isolated tornado threat as well. So let's start off first with the 500 millibar map. This is the GFS that I'm using just to kind of give you an idea of what's going on with the large-scale pattern. You've got this big trough across the northeast U.S. that helped to kick Isaias out of here after several tornado reports across portions of the mid-Atlantic, even down into the Carolinas, up through just to the south of the New York City area. Portions of New England also had some tornadoes associated with that system. And here we've got a little bit of an interesting pattern that is quite favorable for high plains. You can see this relatively strong flow here. It is a textbook northwesterly flow system, but really what you want for the high plains to go nuts out here is zonal flow, some modest mid and upper level flow beneath low level easterlies in a post-frontal environment to gain just a little bit more moisture to bring those cloud bases down. And that's exactly what we have so far today. Even though so far this season it's been quite dry across the high plains compared to the last few years, and that's kept the cloud bases just a little bit too high to realize a robust tornado threat like we had over the last 2 years. But the moisture is a little bit higher today than it has been previous days. You can see a bit of a trough here in California, and then a very tight anticyclone, as is often happens during this season, during monsoon season. Usually that anticyclone is centered over the Four Corners region, pumps moisture northward on the backside through the Sea of Cortez, and that can energize the southwestern U.S. monsoon. But sometimes that high will shift a little bit east or be almost non-existent, and that usually means that the central and northern high plains are going to be active for severe weather. So one thing I've noticed in my several years of monitoring the southwestern U.S. monsoon and the high plains severe weather is they do seem to be inversely correlated. So like last year when there was a really active July and August across the high plains, it was almost a non-existent monsoon season. This year is a little bit less of an active high plains season, medium sized southwest U.S. monsoon. There have been some debris plugs down there, some flash flood warnings, but nothing like 2 years ago when the southwest U.S. monsoon was just nuts with haboobs almost every single day, flash floods, debris plugs in southern Utah to northern Arizona. I was chasing with David Rankin back then, the notorious flash flood expert out there in the southwest U.S., and he got me on some pretty incredible debris plugs down near the Big Water, Utah area, down into Page, Arizona. Those are some of the more intense natural phenomena that I've ever chased. Running along the leading edge of that debris plug was definitely an intense experience, probably similar to running with the bulls, I would say. But those debris plugs don't move incredibly fast up there in the Grand Staircase of southern Utah, so it does give you the opportunity to run along the leading edge and then get out of that wash just ahead of it. Certainly I wouldn't recommend that for anybody here. But one thing I'm noticing here in the upper levels are that it's a bit stronger up into the Wyoming and northern Colorado side. So even though at least initial surface maps are showing better moisture along the I-70 corridor into the Palmer Divide, you're going to give a little bit back with weaker upper level flow. In fact, really marginal bulk shear for supercells down there near the greater moisture area of the Palmer Divide. More than enough bulk shear though across southeastern Wyoming into northeastern Colorado. And you're going to see that in the maps that I'm going to show you ahead. So I've really got to decide between chasing the greater bulk shear, higher dew point spreads up in southeastern Wyoming into northeastern Colorado, or those lower cloud bases, a little bit less bulk shear off the Palmer Divide. So that's really what the decision is so far. So now let's look at the surface map. It's always so important to look at those real observations when you're chasing in the high plains. These are real observations from just a little bit ago. And you can see that the moisture plume up here into southeastern Wyoming is quite a bit less. But then you've got these mid to upper 50s dew points in the Nebraska Panhandle into southeastern Wyoming up near the Lusk area. That wouldn't be a bad area to target. It looks like you're going to be talking about an 85 over 55 type of an environment up into southeastern Wyoming, 30-degree dew point spreads. And then you've got some better dew points down here along the I-70 corridor, up along the Front Range. You've got some upper 50s dew points so far this morning. Lyman looking at a 75 over 57. But most of those robust easterlies are also in northeastern Colorado into southeastern Wyoming up there. And but most of the models do bring these winds down near the I-70 corridor into the Palmer Divide over to an east to west direction. Colorado Springs is checking in with 71 over 55. Look at the big dew points down here in southeastern Colorado too. A little bit even more removed from the stronger mid and upper level flow that we're having up into southeastern Wyoming into northeastern Colorado. So really it could be that the Palmer Divide is kind of splitting the difference. You've got decent moisture, you've got just enough mid and upper level flow to get those transient supercell structures. But boy, I like this environment up a little bit further north of Cheyenne too. Nebraska Panhandle feeding into the Lusk up to the Douglas area. Temperatures will be a little bit lower up there. Bulk shear will be a lot higher up on the Wyoming side. And looking at the forecast dew points, these are the 3-kilometer NAM dew points. I don't like to use the HRRR for the high plains because it usually overmixes those dew points, leading to a drier environment that actually happens. But here you can see these low to mid 50s dew points streaming in Nebraska Panhandle into southeastern Wyoming. You've got slightly better dew points though down into the Palmer Divide, even a 59, 58 dew point anchored up against the terrain down there to the south of Denver. So that's the positive that you have down along the I-70 corridor with the deeper moisture, lower cloud bases down there. But you've got better wind shear up into southeastern Wyoming with dew points low to mid 50s. Temperatures will be a little bit lower though. We're going to analyze soundings between both of these locations, Palmer Divide or into southeastern Wyoming. Even some enhanced dew points there into north central Colorado, Fort Collins up to Wellington. Certainly could get some big storms up there as well. Now looking at the 0 to 3 kilometer EHIs. As I always mention on here, I usually prefer to look at the 0 to 3 kilometer shear indices as opposed to the lowest kilometer, and that's because here across the high plains, you usually get easterly winds in the lowest kilometer or two, flipping around to those modest westerlies in the mid-levels. So usually the 0 to 1 kilometer indices don't capture the true magnitude of the wind shear up here against the high plains, but those 0 to 3 kilometer indices are better at capturing the true magnitude of the wind shear out here. So you've got a plume going from the Nebraska Panhandle into southeastern Wyoming, and these are EHIs, so this one's probably dominated more by the wind shear, whereas these EHIs into the Palmer Divide are likely dominated by the greater moisture, greater instability out there. The EHI is a composite index between surface-based CAPE and the storm relative helicity in that layer. So you really got to be careful to break down those individual ingredients, look at the cape, look at the wind shears separately to see what is contributing to that. And we're going to pull a photograph from southeastern Wyoming and another one from down here near the Black Forest area and examine the thermodynamics and how the wind shear is different between those two target areas. So first, let's look at the storm relative helicity component of the 0 to 3 kilometer EHIs. And here you can see overall the kinematics or the wind shear is a little bit better in southeastern Wyoming as compared to down south, but you've got lower cloud bases down off the Palmer Divide. This is a magical place for producing tornadoes, even in modest bulk shear environments. You can get a funneling of those easterlies into the gaps in the terrain there. And you've got some lower cloud bases. So really you got to decide, pick your poison. Do you like the kinematics, better wind shear with higher cloud bases? Or do you like the lower cloud bases, marginal deep layer shear, but still some easterlies funneling into the gap of the terrain? And so let's look at some forecast soundings. This is the photograph from the Wyoming area. And there you can see those dew points a bit more marginal. You're looking at a 86 over 53 type of a kinematic environment or a thermodynamic environment. A little bit drier than it should be. You can see the mixing out of those dew points. And this is a 3 kilometer NAM forecast sounding up there. But you can see these low level easterlies all the way up to about 2 kilometers. And then flipping over to westerly, and that's why I like to use the 3 kilometer indices, because then you're actually capturing this flip around from east over to a westerly direction. Here you can see the easterlies in the photograph at the low levels, and there you can see the strong mid-level flow that leads to bulk shear in excess of 30 to 40 knots. That's why you're going to get supercells up here. A lot of dry air coming in at the mid-levels too, so there is quite a bit of instability happening here, some steeper lapse rates. There you can see the cape as well in this layer. But you can see the inverted V soundings at the low levels, and that's contributing to higher cloud bases than you might see down near the Palmer Divide. But boy, do you have some big time 500 to 300 millibar winds out of the west-northwest, 30, 40, 45 knots up there. That's why we've got a threat of very large hail, supercell storms, bulk shear in excess of 40 to 50 knots. There's going to be supercells all over the place. And usually you like to see more of a curved photograph out here, but when you get these southerly moving storm motions, south-southeast at 20 knots, that basically creates its own low-level jet, creates its own storm relative wind shear. And you can see in the photograph here, the area enclosed by the photograph curve and that storm motion vector there is proportional to that storm relative wind shear. And there definitely is going to be plenty of streamwise vorticity intake in the lowest 3 kilometers there with these storms. And that's why there is an isolated tornado threat. But with these inverted V soundings, the threat up into southeastern Wyoming really hinges on how low those cloud bases can be. Sometimes, though, you can get pockets of higher moisture up there. Looking at the morning surface map, there are some upper 50s dew points in the central Nebraska Panhandle. That could help to maintain that moisture just a little bit. But boy, is it a little bit hotter out here in the high plains, a little bit drier than it has been in recent years, and that's why we do have these relatively high cloud bases. So now let's look at a photograph down near the Palmer Divide, and you can see that shear-wise, it's actually not that much worse down off the Palmer Divide. You've got 35 to 40 knots at 500 to 300 millibars, so even though it looked like on the GFS that the Palmer Divide might be a little bit further south of that better wind shear, the 3 kilometer NAM is suggesting that may not be the case, and there actually is plenty of bulk shear up here for these storms. And you have the classic shift from southeasterly winds to southwesterly and then westerly loft in the lowest 3 kilometers. Dew point of about 60 here. That's a little bit more favorable than up into southeastern Wyoming. Temperature just a little bit below 90. But once those storms start to develop and send out some anvil shadows, that should help to moderate those surface temperatures just a little bit, maybe bring those down into the mid-80s. If you're talking about an 85 over 59 type of a thermodynamic profile, then I do think there's going to be a pretty substantial tornado threat. We also have this decent elevated mix layer here, dry air coming in at the mid-levels of the atmosphere, contributing to much greater cape down to the south, and a little bit deeper moisture too. A little bit less of an inverted V sounding here at the low levels. A little bit of a capping inversion too that should help to inhibit storms from forming off the terrain just a little bit too early. And look at this photograph, a little bit more cyclonic curvature noted with this photograph, with a little bit less mixing, a little bit greater dew points. You've still got the south-southeast storm motion at about 15 knots, creating quite a bit of storm relative wind shear in this environment here. So I think I might end up just playing the Palmer Divide on this one instead of Wyoming. I know I normally do chase Wyoming during these situations, but I'm feeling like the Palmer Divide could be a little bit better. Let's see what the HRRR shows, even though I really don't like the HRRR here in the high plains. The HRRR does have a little bit better 0 to 3 kilometer helicity streaming up into southeastern Wyoming. 0 to 3 kilometer shear you can see is favoring a bit of a Palmer Divide storm down here too on the HRRR. Looks like even close to 200 0 to 3 kilometer storm relative helicity up there. But look at what it does to the dew points. The HRRR mixes it out to a 50 dew point down there up the Palmer Divide, 87 over 50, 37 degree dew point spreads. I just don't see that happening, but that's why I like to throw out the HRRR out here in the high plains, because it has a tendency of over mixing the dew points. Look at that, it mixes it down to a 41 up in southeastern Wyoming, 50 degree dew point spreads. That's just not going to happen. So we really should throw out this model, because those moist easterlies are going to maintain those dew points. But still, the HRRR is right for the wrong reasons. It's got some decent supercells in southeastern Wyoming, a decent supercell off the Palmer Divide down near the Black Forest area. So it still is good at predicting where those storms are going to form, but how they evolve after that, it's just too dry by the HRRR. So it shows storms collapsing, splitting all over the place, and really we want to throw that model out. Looking at the 0 to 3 kilometer NAM, even though this is not a convective allowing model, it's also right. Has supercells forming here in southeastern Wyoming. Other supercells forming off the Palmer Divide. This is at about 3 p.m. Has these ones evolving off to the southeast, south of Lyman area. Has the northeastern Colorado ones junking out a little bit with that drier environment. So just a little bit better dew points feeding in to the southeastern Colorado target. Some of these dew points by 22Z are because of storms passing through the area, dropping some outflow. Really, you're looking at mid-50s out there in northeastern Colorado, with upper 50s streaming into the Palmer Divide. So definitely what I'm seeing here is the Palmer Divide wind shear is almost as favorable as southeastern Wyoming. Here you can see you got about 30 knots at 500 millibars as opposed to 35 to 40 knots in southeastern Wyoming. So a little bit less mid-level shear, mid-level flow. But ramping up with time between 3 p.m. and 6 p.m., that flow really increases quite a bit. So I could see this being a little bit of a later show also, looking at 700 millibars. A little bit of a low-level jet indicated out here, 15 to 20 knots. 850 should be a better representation of the easterlies. I really wish that you could customize the pressure layers that you look at. Just gonna have to go with the surface out here, because 850 is actually below the surface in many locations. But you basically have the southeasterlies funneling into the Palmer Divide. You've got plenty of easterlies across northeastern Colorado into southeastern Wyoming, funneling through the Nebraska Panhandle. But it looks like just some slightly stronger southeasterlies out here that could compensate for about 10 knots less at 500 millibars, kind of equalizing the bulk shear between those two locations. Just for the hell of it, let's look at 0 to 6 kilometer bulk shear through the target area. And look at the Palmer Divide. So those stronger southeasterlies actually compensate for about 10 knot weaker 500 millibar winds. But you can see overall, the bulk shear still is best in the southeastern Wyoming. with this pipe of southeasterlies beneath accelerating mid-level flow, but still decent, 40 to 50 knots of bulk shear down here with better moisture in the Palmer Divide. We're going to have a lot less bulk shear at 21Z, but still plenty of bulk shear up to 50 knots up there in northeastern Colorado with those greater easterlies. But you can see how the bulk shear does tail off just a little bit down near the Palmer Divide, and you've got 50 knots of bulk shear up here in southeastern Wyoming. Quite a difference there. That's at 21Z. And it's because of all these really strong winds up to 6 kilometers and above. You got about an 83/54 up there in southeastern Wyoming. So about a 29-degree spread. And then down here in that 0 to 3 kilometer plume feeding into the Palmer Divide, you're looking at about 85/60. So I think that the tornado threat's just a little bit higher down off the Palmer Divide, but don't be surprised if there's something big time in southeastern Wyoming. Also, don't be surprised if I do end up heading up there anyway. But this is what we're looking at for High Plains Insanity today. Here's Gizmo again. Getting ready to chase today. Big hail is going to be the main threat today with these southeasterly movers at about 20 knots. But there is definitely going to be a threat of a tornado or two. I'm going to be streaming live. Thank you, Facebook supporters, so much for everything, for supporting these live briefings, live storm chasing, and our Team Dominator Science. I just spoke to Mark this morning, and it looks like the subsonic sensor is going to be ready in time for potential tropical cyclone Josephine. That looks like it could form around the middle of August out in the open Atlantic. So we're keeping a close eye on that as well. And it looks like we'll be rolling on all cylinders with our science in time for the next big tropical system that comes. So no more tropical storm Isaias's. We're going to be chasing everything from here on out. If there's a tropical cyclone coming in, if it's a Cat 1 hurricane, if it's a tropical storm, tropical depression, we'll be on it. It used to be, Joel and I wouldn't chase a tropical cyclone unless it had the potential of being a Category 3 or higher, which ended up being basically Category 2 or higher. But now, with all the hype on these tropical cyclones that impact the eastern U.S., we basically just have to chase everything. Tropical storm, Cat 1 hurricane, Cat 5 hurricane. We need to be there doing science. And a lot of times these more modest tropical cyclones will be prolific tornado producers and produce outbreaks of tornadoes, like we just saw with Isaias. Dozens of tornadoes produced, including some that appeared to be quite damaging, and that's why we got to be out there chasing it all. So thank you, everybody. Enjoy the rest of your day here, and I'll be out streaming live starting in about 3 hours, intercepting these storms. Still undecided as to whether I'll be southeastern Wyoming or the Palmer Divide, but I am leaning strongly toward the greater dew points down there to the south of Denver, off the Palmer Divide, and still very strong bulk wind shear values, 40 to 50 knots. So thank you, everybody. Hope you enjoy my weather reports. Never stop chasing.